Welcome, geometry students, to section 4.6. This is hypotenuse-leg. We've already been talking about some different ways that you can declare certain triangles congruent to each other. We talked about angle, side, angle, and we labeled these with 3 letters, by the way. Side, angle, side, angle, angle, side, also known as SAA. And we also talked about side, side, side. Now we're going to talk about a 5th one. Now, before we talked also about how ASS or SSA is not a congruence theorem. Okay, there's 2 different triangles you can create with that, so that is not one. However, this newest one we're about to learn kind of puts a little twist on the never, never, never for the ASS SSA. Okay, but I don't even want you to consider SSA. Put that one aside. This is a new one you're going to learn today. And I hope my explanation will clear this up in just a second. So the first thing we got to talk about is this particular theorem is only for right triangles, okay? Now, we need to label some of the parts of a right triangle. So one of the parts we have, well, let's use this color, is the hypotenuse. Okay, there has to be a hypotenuse with a right triangle. Okay, so let's change the style here a second. Go back to a thinner style. There we go. And with the other sides, we have legs, is what we call them. We call them legs. Okay, so we have hypotenuse and we have legs. Okay, so the legs are the sides of the triangle that form the 90-degree angle, and the hypotenuse is the side opposite the 90-degree angle, okay, not touching the 90-degree angle. Okay, now that we know where the parts and how we call the parts, we can understand what the hypotenuse-leg theorem is. So, if we know that these two are right triangles, so we're going to call this triangle PQR and triangle XYZ are right triangles. Okay, so they have to be right triangles. Okay, and actually there's too much information given here. We want to reduce this. Actually, no, this is good. I take that back. So the other information, so these are both right triangles, so that, as you can tell here, okay, they're both right triangles. Actually, I'm going to highlight that just so you can see each little thing that we're talking about. So we got that, and we want to know that, we'll change the color, PQ is congruent to XY. And then one more thing, we need to know that PR is congruent to XZ. Now, what does this mean? Well, this is our hypotenuse, okay? This is our leg, and we're talking about right triangles, okay? So if we know that these are right triangles, as indicated by the angle, and they have a leg and a hypotenuse that are congruent, then we know the 2 triangles are congruent. So we can say triangle PQR is congruent to triangle XYZ. So not only are their angles, right angles, congruent, but these angles will also be congruent. Let's just go with 2. These angles will also be congruent, and then this side will also be congruent. Okay, so that information, the hypotenuse and leg in right triangles, helps us determine that 2 other triangles are congruent. So what are the conditions? Well, we already talked about them. They both need to be, we need right triangles, we need right angles. So there has to be a right angle in there in the triangle. There has to be a congruent leg. And there has to be a congruent hypotenuse. Okay, so right angle, this is, or I'll just put right triangles. That's a better way to put it. Hopefully you didn't write it down already. If you did, I'm sorry. Right triangles with a congruent leg and a congruent hypotenuse. Okay, so we're going to take a look at the example here. Are the triangles congruent? If so, make a congruence statement. I think it's just congruent statement, but back in the day. Anyway, are the triangles congruent? So let's take a look. Well, we got a clue here. The clue is we have a right triangle here. Okay, what else we got? We have a congruent side. Okay, and then we have, hopefully we're experts at this by now, we have the reflexive property going on. Reflexive property, meaning that they share a side, so it's congruent for both triangles. So this is reflexive. 1, 2, 3. Okay, so because we have a congruent side and then a congruent leg, and they're both right triangles, these are going to be congruent. Let's name the triangles. We have triangle. Let's go ACS, and then triangle ARS. It is important the way you label it. Again, we're going to go from this small acute point here to the right angle, and then to the other angle, okay? So we're going to name it in the same sequence for both triangles. Again, if you want to separate your triangles, which I often do to distinguish the two, here's my first triangle. Ooh, ugly. I hate that. Try this again. Not great, but I'll live with it. And here's my second triangle. So I have to label it in the same order of sides or angles, okay? So because I knew the hypotenuse and the leg are congruent, then those two triangles are congruent. Okay, let's take a look at these two triangles. If you want to label the triangles first, just to get an idea of where they are. Okay, we got the, oh my gosh. We got the green one, then we got the purple one. Okay. What do we know about them? Well, we know that if this is 90 degrees, what do we know about this one? Well, these are vertical angles, so this also has to be 90 degrees. Those are congruent. Now we also know that there's a hypotenuse congruent and there's a leg. So this is going to be HL. Oh, I forgot to say that these were HL. So this is HL. That's your new congruent statement. It's not three letters like it was before, like side equals side. It's HL. And you're not going to put ASS either, okay? The only time we can use HL is when we use right triangles. It's right triangles only. It's an exclusive club. Only right triangles are allowed. So this one's also congruent. Let's name the triangles that are congruent. We're going to start with the right angle for both. So let's go triangle B, and we're going to go along the two side here. So BGO is congruent to, let's go again. Start at the right angle, BUL, and those are our two triangles. Okay, so we have our two triangles here, and it's congruent because of HL. And that's all we have. This is our fifth and final congruent statement, HL. Hope you guys enjoyed this video. Thanks for watching, and stay tuned for next time where we go over more examples on how to do this.